Welcome to the Explainer. Let's get right into it. Today's focus is Input-Output Source-Based Model Video Overview. STEM-Python-STEM-Python Unit-03 Lesson Pack 01 Input-Output-Source-Based-Model-Video Overview. We're going to completely change the way you look at data flowing through your code, so let's jump in. Welcome, Grade 7 students. The goal for us today is absolutely crucial for your journey as programmers. We're going to master exactly how Python receives, processes, and communicates values, and we're not just guessing here. We're going to use a really strict source-based pipeline. That means we're tracking our data at every single stage, from the very moment it enters our program to the exact second it leaves. It's all about control, precision, and truly understanding the nature of the data we're working with. Section 1. Misconception check. Debunk and rebuild. Okay. Let's dive into this by tackling probably the biggest trap new programmers fall into. Just imagine you're writing a program. You ask a user for a number, or maybe you read a file, and Python sees the characters 1, 2, and 3. Right away, our human brains look at that and go, that's 123. I can add that, I can subtract it, I am ready for some math. But here's the catch. If you assume Python automatically treats this input as a mathematical number, you are literally walking right into a bug.
So, the crucial point is this. Conceptually, you absolutely must separate a text string from a mathematical integer. Think about the string 1, 2, 3 wrapped in quotes. To Python, that's just a sequence of text characters. It's a 1, followed by a 2, followed by a 3. It's just text, exactly like the word apple. Now contrast that with the numeric value 123 with no quotes whatsoever. That is an integer Python can actually do math with. So when Python reads data in from the outside world, it definitely does not default to being an integer. It defaults to being text.
Section 2. Documentation evidence, checking the manual.
In programming, we don't guess, right? We check the manual. And the official Python documentation brilliantly illustrates exactly what we were just talking about. Pulling directly from section 7.2.2 of the docs, it explicitly states that the read method only returns strings, which will have to be passed to a function like int, which takes a string like 123 and returns its numeric value 123. So the documentation completely debunks our misconception. Python receives text, and it's entirely up to you, the programmer, to actively transform it if you actually want a usable number.
Section 3. Application, the input transformation.
Now that we've debunked that tricky misconception, let's rebuild things using our 5-step source-based model pipeline. You're going to want to memorize this. Step 1. Identify our source or requirement. Basically, what are we actually trying to do? Step 2, look at our raw inputs. What data did we actually receive? Step 3, the transformation. What specific Python function do we use to change this data into what we need? Step 4, expected outputs. What should the data look like after that transformation? And finally, step 5, check. How do we literally prove that it worked? This pipeline is going to be your best friend. Let's map that exact example from the Python documentation right onto our pipeline. Looking at stage 2, our input is the string 123 wrapped in quotes. Stage 3 is our transformation step, where we apply the int function directly to that string. And then stage 4 shows our expected output, the clean numeric integer 123 with no quotes at all. We've successfully taken raw text and transformed it into a math-ready integer. Boom.
Section 4. Limitation and human check. Part of mastering this whole model is understanding that things aren't always perfect. According to section 7.21 of the docs, there's actually a pretty serious limitation if you aren't careful. When reading from a file, if you omit the size argument, Python is going to try to read the entire contents at once. The documentation bluntly states a major risk here. It's your problem if the file is twice as large as your machine's memory. It will absolutely crash your computer. This just highlights exactly why we need strict control over our inputs and why having a quick display check tool for debugging is so important before things spiral out of control.
Now, what's really interesting here is how we prevent those disasters. We use our check tool, the repr function. Unlike a standard print statement, which basically tries to make things look pretty for humans, repr generates a representation specifically designed to be read by the Python interpreter itself. So why is this a superpower? Well, if you have a string that says 123, repr will forcefully display those string quotes around it right in your console. It leaves zero doubt. It's basically your ultimate human in evidence check to instantly verify if your data is text or a real mathematical integer.
Section 5. Transfer. Formatted communication.
Let's move on and see how this all builds into our final step. Now we actually have to communicate our process data clearly back to the user. We call this a transfer task.
Let's look at some brand new inputs straight out of section 7.1.1 of the documentation. We've got two variables. The first is year, which is holding the numeric integer 2016. The second is event, which is holding the text string referendum. We need to combine these two completely different data types into one clean, highly readable output sentence.
To pull this off, we use a transformation known as formatted string literals, or F strings for short. By just dropping an F right before our opening quote, we can insert our variables directly inside curly braces. Just look at the expression, F, quote, results of the year event, end quote. Python takes that integer, 2016, automatically handles the conversion to text for you, and injects it seamlessly alongside the string referendum. The output is perfectly formatted, results of the 2016 referendum. This is exactly how we successfully communicate processed values back out to the world.
So as we wrap things up today, I want you to ask yourself a question. Are you trusting your assumptions or are you trusting your pipeline? Because at the end of the day, computers only understand your exact instructions. If you rely on truly understanding your inputs, purposefully transforming them, and meticulously checking your work, you are going to write bulletproof code. Keep coding, keep checking those sources, and I'll see you next time. For Input-Output, Source Space Model Video Overview, STAM Python, Unit 03, Lesson Pack 01, Input-Output, Source Space Model Video Overview.